Forget everything you were ever taught in school. Forget the diagrams in your old textbooks and the simple labels you grew up with. The planet Jupiter is not what you think it is. For decades, we've called it a gas giant, as if it were nothing more than a giant floating balloon in the dark. But that is a lie. Or at the very least, it is a massive misunderstanding. Jupiter is not a ball of gas. It is a liquid world, a realm of liquid metal, and a place where the laws of physics are pushed to their absolute breaking point. Before we dive deep into this metallic abyss, if you enjoy uncovering the secrets of our universe, make sure to hit that subscribe button and join our community of space explorers. Now, let's peel back the clouds and see what's really hiding inside the King of Planets. Our journey into the truth began decades ago. Imagine the year 1974. A small, lonely spacecraft called Pioneer 11 captured the very first close-up photograph of Jupiter. It was grainy, it was distant, but it was a revelation. 5 years later, Voyager 1 gave us the first moving picture, a time-lapse that showed the swirling, chaotic dance of its atmosphere for the very first time. These images were beautiful, mesmerizing, but they were also a mask. They showed us the cool exterior, but they couldn't tell us what this monster was actually made of. To understand Jupiter, you first have to understand its scale. It is difficult for the human mind to truly comprehend how massive this world is. Jupiter is heavier than every other planet in our solar system combined. It is so vast that you could fit 1,000 Earths inside its belly. If our Earth were the size of a tiny grape, Jupiter would be a massive basketball. It sits there in the cold dark, a heavyweight champion that dictates the gravity of everything around it. For a long time, scientists had two theories about how this giant was born. The first theory suggests a violent beginning. A disk of rock and metal spinning around a young sun, where chunks of debris smashed together for millions of years. Eventually, one chunk became so large that its gravity began to vacuum up all the gas in its path. If this were true, Jupiter would have a solid, rocky heart. The second theory is even wilder. It suggests Jupiter started as its own separate cloud of gas, a failed star that collapsed under its own weight. If that were the case, Jupiter wouldn't have a core at all. It would be a layer cake of nothing but gas. But as it turns out, both of these theories were wrong. The real breakthrough happened in July 1995. It was a cosmic event that happens only once every 6,000 years. A comet named Shoemaker-Levy 9 was screaming through space at over 200,000 kilometers per hour. Jupiter's gravity was so powerful that it ripped the comet into 21 separate pieces. At that exact moment, NASA's Galileo spacecraft was arriving. It had a front-row seat to the most energetic explosion ever caught on camera. The largest fragment hit with the energy of 300 million atomic bombs. It punched holes in the atmosphere, kicking the insides of Jupiter out into space. And that is when we saw it. When the Galileo probe flew through that debris, it found something unexpected. Water. Massive amounts of water. This discovery changed everything. It led to the Juno mission in 2011, a spacecraft designed to solve the mystery of Jupiter's core once and for all. What Juno found over the last decade has completely rewritten our science books. Let's start at the top. The clouds you see in photos? They are a thin, freezing shell, barely 50 kilometers deep. The temperature there is a bone-chilling -100 degrees Celsius. Ammonia acts as a natural antifreeze, allowing liquid water to exist even in the freezing heights. This creates a terrifying weather system. Imagine slushy hailstones falling through the sky, colliding and creating static electricity that triggers lightning storms 10 times more powerful than anything on Earth. As we descend further, the ammonia rain evaporates, and we reach the Great Red Spot. This isn't just a storm, it is a vertical monster. It is 10 times taller than Mount Everest and 10 times deeper than Earth's deepest ocean. It reaches so high into the atmosphere that it absorbs UV light from the sun, turning that iconic deep blood red color. It is a skyscraper of wind and chemistry, but even this is just the surface. The deeper you go, the more the environment changes from a storm into a furnace. As gravity pulls everything toward the center, the pressure becomes unfathomable. This pressure creates heat. The hydrogen gas begins to compress. It gets thicker and thicker, turning into a dense fog, then a mist, and eventually it transitions into a liquid. At a depth of 1,000 kilometers, the gas is gone. You are now standing on the shore of the largest ocean in the solar system, an ocean of liquid hydrogen. This is where Jupiter stops being a planet as we know it and becomes something alien. On Earth, we have to freeze hydrogen to make it liquid, but on Jupiter, the pressure is so high that the hydrogen stays liquid even at temperatures over 1,000 degrees. This boiling ocean is 20,000 kilometers deep, but as you reach the bottom of this ocean, the pressure reaches millions of times that of Earth's surface. At 10,000 degrees Celsius, something magical happens to the atoms. The hydrogen changes state into metallic hydrogen. It is no longer a simple gas or a simple liquid. It becomes a substance that can conduct electricity. Electrons are squeezed so hard they break free from their atoms, flowing like a river through the liquid. This creates a massive electric current, the engine that powers Jupiter's colossal magnetic field. Most of Jupiter is made of this strange, glowing metallic liquid. But what lies at the very center? For years, we thought there was a solid ball of rock the size of Earth, but Juno's data tells a different story. Jupiter has what scientists call a fuzzy core. There is no hard line where the liquid metal ends and the solid rock begins. Instead, it's a dense soup. Rock, metal, and liquid are all stirred together in a chaotic, blurry mess that spans half the planet's radius. How did the core become fuzzy? Some believe that in the early days of the solar system, a rocky planet 10 times the size of Earth slammed into Jupiter. The impact was so violent that it shattered Jupiter's solid core, melting it and mixing it with the surrounding layers. Computer simulations show that while most cores should solidify back into a ball, Jupiter's core stayed messy. It stayed weird. To this day, we don't fully understand why Jupiter refuses to follow the rules. It is a giant mystery wrapped in clouds of ammonia, a world of liquid metal that challenges our understanding of how planets are born. It is a reminder that the universe is far stranger than our classrooms ever led us to believe. We are only just beginning to scratch the surface of this metallic titan. Jupiter is a world of contradictions, and there is still so much more to discover. What do you think? Does the idea of a liquid metal planet change the way you look at the night sky? Or do you think there are even bigger secrets hiding in that fuzzy core? Let me know your thoughts in the comments below. I read every single one of them. Thank you for watching, and I'll see you in the next exploration.